For decades, the Collatz conjecture has been viewed through the lens of classical integer arithmetic. Today, we are going to walk through a completely unified, unconditional mathematical proof of the conjecture. This diagram illustrates the core flaw in previous attempts, the Diophantine obstruction. When we isolate prime powers, we hit an unsolvable tension between the 2-adic valuation of dividing by 2, which shrinks the number, and the 3-adic growth of multiplying by 3, which expands it. The Adelic transition treats these trajectories as global state vectors across the entire Adelic spectrum. This allows us to reconcile the mismatch between division and multiplication by utilizing a holographic buffer to resolve discrepancies between different prime scales. This balancing scale diagram presents the cornerstone of the proof, the universal product formula. It enforces rigorous consistency across the 2-adic, p-adic, and Archimedean places. Because the product of all valuations across these places must equal exactly 1, the formula maintains a global parity. This ensures that any arithmetic discrepancy in one scale cannot be sequestered or hidden. It must be balanced by the others, effectively preventing random anomalies from forming. This table outlines our divide-and-conquer strategy for the proof. We partition the Adele ring into 2 distinct sections, an infinite ceiling above and a finite floor below. The exact boundary dividing these 2 regions is K0. Above this threshold, we rely on asymptotic growth bounds. Below it, the governing arithmetic laws of the Adelic framework take over entirely. Looking at regime 1, the Archimedean ceiling, this equation defines the mismatch metric, lambda. By applying Baker-Wust-Holtz bounds, we measure the phase discrepancy between real and p-adic scales for massive trajectories, where k is greater than k0. The metric proves that for trajectories larger than k0, the arithmetic entropy required to sustain a closed loop exceeds the capacity of the underlying restricted tensor Hilbert space. At these lengths, the Archimedean phase discrepancy makes a non-trivial cycle impossible, leaving only the finite region left to solve. Moving down to regime 2, the floor where k is less than or equal to k0, the solid 2-adic dynamics are governed by exact Mahler coefficients. To prevent spectral drift across these non-local carry bits, we apply this simultaneous weighting scheme. The transfer operator branches require a precise handle. This block shows the even branch theorem, which behaves cleanly, offering a closed-form Mahler expansion with predictable diagonal valuation growth. The odd branch theorem introduces our primary complexity. It is entirely constrained by this verified Mahler product formula, centered on a specific combinatorial multinomial identity in the denominator. Let's see how this plays out on the critical diagonal, where u equals n plus 1. We apply Kummer's theorem to find the 2-adic valuation for both even and odd values of n. Pause the video here, grab some scratch paper, and calculate how selecting an even versus an odd number for n changes the dominance of the summands before we move on. Here are the outcomes. When n is even, you get a unique dominant term of valuation 1. But when n is odd, multiple summands reach comparable valuations and clash, completely breaking that unique dominance. These branch matrix theorems successfully lock the finite region. We have replaced stochastic empirical observations with tightly bounded, closed-form combinatorial logic. This flowchart maps the unified deductive chain. We trace how local uniform nuclearity passes residual continuity into the completed operator, yielding the global Adelic factorization. This chain is backed up by strict trace class ceilings in the Archimedean liquid regime. The infinite place forces a firm limit of exactly 2700. When we pass unit content through the Adelic factorization, we find there is no surplus arithmetic volume within the ring. The global arithmetic ledger mathematically snaps shut. By balancing the solid 2-adic dynamics and the liquid Archimedean limits under the universal product formula, we find the system's arithmetic ledger is closed. With 0 spectral capacity left for deviation, the trajectory is forced into the only remaining state permitted by these laws of global reciprocity, the 1-4-2 cycle.